Hello sir, we are the Voltestry and we're going to report the wind turbine. So this is the example of a wind turbine. So what is a wind turbine? A wind turbine is a type of a renewable energy that harnesses the power wind to produce electricity. So the basic idea is that wind turbines uses rotor with attached blades to collect wind's potential and kinetic energy. Wind turns the blades, which spins a shaft that is connected to a generator which results in generation of electricity. So basically, yung wind turbine ang nagpapagana sa kanya is yung wind. And then, kapag umikot yung wind turbine, magde-generate na siya ng electricity. A large number of wind turbine is usually called wind farm. And here's the part of the wind turbine. So ito yung mas malinaw. So we have the rotor. Ito yung malaking LC na to. And then we have the blades. And then after nun yung low speed shaft. And then yung gearbox. Yan siya para kapag umikot. And then ito yung generator. Then after nun, ito yung high speed shaft na mas mabilis. And then yung controller. After nun is yung anemometer. Then yung nozzle and then yung wind vane. And then parts and functions. Blade. The blade is the part that relates due to the force attached from the wind. It is connected to the low speed shaft via the hub. The low speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of generator, thereby generating electricity. Most wind turbines consist of 3 blades for maximum efficiency. And yung blade design. To produce an amount of power wind, turbine blades generally need to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvement in the design has produced new wind turbines which are more compact, quieter, and generates more power from less winds. Its length at around 50 meters, which 107 meters, currently the longest from Siemens Gamesa. So dapat yung blades ng wind turbine is mas malaki and mas mataas para mas malaki ma-generate niya ang mga electricity. So ayan yung example ng isang blade ng wind turbine, sobrang laki. Ayan yung blades designs. Airfoils is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade designs. These airfoil designs allow the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and higher efficiencies. Ayan yung mga airfoil designs. So we have tip generation airfoil, 95% radius. Then yung primary outboard airfoil, 75% radius. Then yung root region airfoil, 40% radius. Ito yung thin airfoil family for medium blades. And then yung thick airfoil family for large blades. Tip region airfoil is 95% radius. Ito siya. And then yung primary outboard airfoil, 75% radius. Ito. And then yung root region airfoil is 40% radius. Then next is blade aerodynamics. Wind turbine blades work by generating two aerodynamic forces, lift and drag. Lift and drag. This is due to wind and their airfoils. Lift force is perpendicular to the airflow and is in line with blade rotation. Drag force is the line with the apparent wind direction, which is opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind. So ito yung lift, and then yung drag is yung sa may gawing puno ng blade. ito siya yung lip and drag formula. So, dun sa may lip, ito yung formula niya is L equals C sub L PV squared A sub B over 2. And then yung sa drag is D equals C sub D PV squared A sub bar over 2. So, ayan siya. The next is blade's aerodynamics. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. The most curved side of, or we may say the convex side generates low air pressure while high pressure air pushes on the less curved side, or we may say the side with slightly concave part. This is actually the reason for the blade rotation. Ayan. Aerodynamics. Blade wind orientation. Here is now the question. Based on the figure illustrating the optimum angle of attack, which part of the blade is leading edge and trailing edge, front and back?
Aerodynamics. So, ayan po yung example ng aerodynamics siya. Ayan po sa pictures. Tapos, itong blade rotation. So, question number 1, what will be the rotation of the blade? It is pushed to the side that has more curve, or push to the side that has less curve. Next po. So, ito po yung blade wind orientation. The photo shows the front side and back side as well as the leading edge and trailing edge of the blade. So ito yung example siya ng ito yung example ng wind orientation. And parts and design naman ng blade orientation na to is, in addition is to curve design, twist and tape blades further enhance is aerodynamics with the combined effect of twist and tapering the blade along its length. Improves the angle of attack, increasing speed, efficiency, and lift while reducing drag. Next po. So, number of blades. Here is the question. Based on the previous slide, what number of the blade is the best design in consideration of all the factors in construction and operation of wind turbine? So we have already known that the rear of the blade is curved more than the front. This varied shape causes a pressure between differentially when the air moves across the blade, which is what causes the blade to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in the front of it. It is what set the rotation of the blade in motion. Engineers must consider speed and drag and design the blade to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blades could move quickly, causing them to break the sound barrier. The rule of thumb are the few blades are better since there will be less drag and increase in efficiency. The number of blades increase the torque and reduces the optimum rotation speed. Having fewer blades reduce drag. So ito naman yung number of blade. One blade, because of the decreased drag, one blade will be optimum number when it comes to energy yield. However, one blade could cause the turbine to become unbalanced, and this is not a particular practical choice of the stability of the turbine. And two-blade. At the first glance, two-bladed turbines seem like the optimal configuration for a wind turbine. Perfect, perfectly balanced and with one blade less than three-bladed turbine or blanded turbine. They will regenerate less drag, so aren't all turbines made it two blades. It has troubles in the waving. Yaw is when herd turns to face the wind due to an effect called gyroscopic precession. When a two-blade turbine yaw, it creates a wobble as the blade go from a vertical plane to a horizontal plane, which plane places additional stress on the mounting bearings, wearing and them down faster. So more than three blades. Any number of blade greater than three will be create greater wind resistance. So pagka marami siyang blade, mas maganda yung pagbibigay niya ng hangin or mas malakas. So slowing the generation of electricity and thus become less efficient than three blade turbine. So next one. Three blade. For this reason, turbines designed with blade are are the ideal compromise between high energy yield and greater stability and durability of the turbine itself. And blade tightening mechanism. According to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor-coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity. So that its position is always at the optimum angle of attack. Next one. Nacelle, the house of the back of the blade, which contains the slow speed shaft gearbox generator and the small parts inside it. Gearbox, the component which converts the slow rotation of the blade into faster speed. This indeed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve agreed quality voltage output. Most generators need to be turned at 1500 RMP for 500 Hz and 1800 RMP for 60 Hz. In no way it is feasible for turbine blades to move that fast. So, ito yung sample ng gearbox, yung loob niya. Then, a common ratio is about 90:1 with a rate 16.7 RPM input from the rotor to 1500 RPM output for the generator.
Alternative design, direct drive, or gearless. In a direct turbine, in a direct drive turbine, there is no gearbox. The main shaft spin the generator directly, causing it spin at the same speed of the turbine blades. Comparing to gear type, the slow rotation is moving parts of PMDD generator. Reduce fatigue and stress on the turbine, resulting to reduce noise and vibration, longer lifetime, and lower cost of maintenance. So, yung direct drive is nag-aano siya, yung nagre-reduce siya ng ingay para para magtagal siya and mabawasan yung yung maintenance niya, yung gasto sa maintenance. Direct drive gearless. Important fact that due to wind inconsistency, the gear type turbines often operate at partial loads. The efficiency of PMDD generator excels even this condition because continuous working needed to be nominal values. This design makes suited even offshore wind applications. Next po. So, direct drive gearless is one main disadvantage of PMDD is that to make for slow rotation, more magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than geared type wind turbine. Another thing is that the additional magnets being used in this type made of niobium, which is expensive. Direct drive gearless. The cost and weight of direct drive turbine has prevented it from presenting major competition to gearbox turbines until recently. But other experts claim that direct drive technology will eventually become the dominant one. Since the gearbox wind turbine is almost at its efficiency point, with the VFD generators have more possibilities for improvement. Is yung brake. So yung brake is the brake system in the wind turbine is a protective device that coupled with sensor which automatically stops the rotation of the blades whenever it detects activities that could harm the system during operation. Very high wind speed, vital parts not working, maintenance in power lines, and etc. So yung brake is kusa siyang kumbaga parang pag nadedetect niya na masyado ng malakas yung hangin or pag may ginagawa or may nasira na kusa siyang humihinto. Yun yung brake niya. Automatically siya. Yaw system. Yaw system is sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nacelle on top of the tower so that the set of blades is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electricity energy. Yung tower, so yung tower is yung yung tower naman kasi is yung kung gaano kataas siya, so yung yung tower is wind velocity increase the higher altitude. So pag mataas siya, ibig sabihin mas mataas yung lugar, mas mataas yung makukuha mong wind. And then mas marami madedetect niyang hangin pag sa mataas na lugar kasi mas mahangin sa taas. Yun yung tower. So, ito yung tower and blade diameter ratio. So, papadaas siya, papalaki yung nakukuha ang electricity kasi mas malaki yung nakukuha nilang hangin. And then, pag malaki yung yung range niya, mas marami rin nakukuha na wind and mas marami din na produce na electricity. Ideal location. The best places for wind farms in coastal areas at the top of mountain hills, open plains and gaps in mountains, place where the wind strong and reliable. Some are offshore to the worldwide, there should be average wind speed of over 25 kilometer per hour. So, yung ideal location niya is dapat doon sa mga malalawak and malapit sa mga puno para mas maraming nakukuhang maraming nasasagap na na hangin, and then mas maraming napoproduce na electricity. First and function, advantage. Ang advantage ng wind is free. Wind farms need no fuel, produce no waste or greenhouse gases. The land beneath can usually still be used for farming and good method of supplying energy to remote areas. So, ang disadvantage naman niya is the wind is unpredictable. It changes throughout the day and from season to season. Suitable areas for wind farms are often near the coastal area where the land is expensive, can affect television reception or nearby places. Largest wind farm. Gansu Wind Farm is capacity is 7,965 sa China. And then sa Alta Wind Energy Center, 1,548, California, USA. Mupanda Wind Farm, 1,500, India. Fornesta Project 1, 1,218, UK. Mike Vige Wind Farm, 1,120, Sweden. Jaisalmer Wind Farm, 1,064, India. Gansu Wind Farm. The Gansu Wind Farm project or Jinkon Wind Power Base is a group of large wind farms under construction in western Gansu province in China. In 2008, construction began 750 kV AC power line to carry electricity from the wind farm, and construction of the wind farm then started in 2009. In November 2010, officially announced that the completion of project first phase involving the installation of over 3,500 wind turbines with the installed capacity of approximately 5,160. It has estimated cost of 120 billion Chinese yuan or $17.5 billion. The project is being built by more than 20 developers. Burgos Wind Farm. The 150 MW Burgos Wind Farm is the largest wind farm project in station operated in Burgos, Ilocos Norte, Philippines. The estimated cost for construction of the wind was $450 million US dollar, which was completed in 2015, located within 600 hectare site. The facility consists of 50 wind turbines, each with capacity of 3 MW, generating electricity to the Luzon grid. Each wind turbine rests and tubular steel tower has 75-meter height and a 90-meter rotor diameter. Grid operation. So yung sa wind, ay yung wind, and then yung gearbox, and then yung tower sa generator, power cables, and tower. So yung mga nakukuha nilang electricity is napupunta sa may transformer, and then tsaka pa lang magagamit, tsaka pa lang madadal sa electric power station, and then tsaka pa lang siya magagamit. Hydrogen.
The next one we will report is the hydrogen power plant. By description, a hydrogen power plant is a concept designed for a new, widespread source of electricity. Essentially, it is a facility which uses hydrogen, of course, to produce electrical energy. So, syempre, hydrogen yung magpapagana dito para mag-produce ng energy. So, working principle. Large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. Their fuel cells are solid structure containing an electrolytes, fluid and two terminals, much like batteries. And the neck reactants flow into the cells, in this case hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as a byproduct. The water flows out another part while the electricity is siphoned off the terminals and held in gigantic multi-ton batteries. The electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other types of power plant. So batteries parts and function. So yung mga parts ng battery, so we have electrolyte. So it's a chemical compound that conducts its electricity by charging into ions when melted or dissolved into a solution. So it can be a liquid or paste-like substance. For example, ito is yung ammonium chloride, zinc chloride, potassium hydroxide, lithium tin, phosphorus sulfide, sulfuric acid. So the next one is yung anode. So it is the negative or producing electrode that releases electrons to the external circuit and oxides during the electrochemical reactions. For example, nito is yung mga zinc, metallic, lithium, lead, etc. So the next one is cathode. So it's the positive or oxidizing electrode that acquires electrons from the external circuits and reduced during the electrochemical reactions. So example naman is manganese dioxide, carbon, lead dioxide, and copper. So ito yung schematic diagram ng isang battery. Ayan, we have the electrolyte solutions, the anode, and then yung electron flow, punta rito sa mga cathode. Yung semi-permeable barrier, ito yun. So ito yung battery constructions. So syempre, yung metal cap, so yung positive. Dito yung positive sa taas, and then yung carbon rod, ito yun. Then yung zinc case, yung nagbabalot dun sa may carbon rod. So yung negative electrode. Hindi yung carbon rod is yung positive electrode. Then yung susunod is yung manganese or oxide. And after is yung ito yung kulay puti is yung moist paste of ammonium chloride. So yung electrolyte. And then yung pinaka-bottom is yung metal bottom, which is yung negative. So how it works? There are a couple of chemical reactions within the battery. At the anode, the electrode reacts with the electrolyte in a reaction that produces too many free electrons. As a result, these free electrons repel each other and try to go place with fewer electrons. And meanwhile, at the cathode, another chemical reaction occurs simultaneously that enables that electrode to accept electrons. In a battery, the only place to go is to the cathode, but the separator keeps the electrons from going straight from the anode to the cathode within the battery. And when the circuit is closed, a wire connects the cathode and the anode. The electrons will be able to get the cathode. And so, ano ba rito, Gerald?
So, chemical reaction in zinc carbon battery. Anode, zinc, cathode, magnesium dioxide, carbon is added to increase conductivity. Electro, ammonium chloride. Overall reaction in the cell is zinc plus 2 magnesium dioxide. So note is The exact mechanism of this complicated and there is still controversy over the exact mechanism. However, the approximate half-cell reaction are zinc squared plus 2 electrons. Cathode, hindi ko mabasa. So, yun. Another chemical reaction is the ammonium ion produced to gaseous product. So, this product must be absorbed in order to prevent build up of pressure in vessel. This occurs by two mechanisms. So, next po. So, ito po yung sample ng hydrogen fuel cell. So, may hydrogen fuel, tapos recycling, gas diffusion layer, catalyzed, and proton exchange membrane, gas diffusion layer, air and water vapor, oxygen from air, and cathode. Next. So how fuel cell vehicle works. So single fuel cell hydrogen. Hydrogen is pumped into cell through flow plate. Second is hydrogen molecules split at the anode point where electron from out of the device. A platinum catalyzed a metal that cause chemical reaction split hydrogen molecules into positive hydrogen ions and negative charge electrons. Polymer electromembrane. The polymer electromembrane only allows the positively charged hydrogen ions to pass, forcing the negative electron along the external circuit. This is something like diverting water from a river to power a water wheel. Number 4, electricity. The separated electrons are diverted along an external circuit, creating an electrical current. 5 is oxygen. Outside oxygen is pumped into the cell through a flow plate. 6 is cathode molecules combine. Other catalyzed at the cathode point where electrons enter a device causes the negatively charged electrons and positively charged hydrogen ions to combine with oxygen to form water, 2 hydrogen molecules plus 1 hydrogen molecules. So 7 is water. Oxygen combines with hydrogen molecules to make water which exists the cell. So yung ganyan po gumana ang fuel cell vehicle. Hydrogen fuel cell. So fuel cell work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. So, itong fuel cell ay hindi para siyang, pagka gumagana siya para siyang battery. So, pero hindi siya gumagana hindi na siya kailangang i-charge kung ito ay hindi na siya gumagana ganyan. So, nagpo-produce siya ng electricity and heat kapag may gas or fuel na supply. A fuel cell consists of 2 electrodes, a negative electrode or anode, and a positive electrode or cathode, sandwiched around an electro. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. In hydrogen fuel cell, catalysts at the anode separate hydrogen molecules into protons and electrons, which take different paths of the cathode. The electrons go through an electric circuit creating the flow of circuit electricity of protons migrate through the electrons to produce water and heat.
Next si Andre. Si Michelle natin. Wait lang.
Ano sa diagram?
O, tama si Michelle na. Hindi.
Schematic diagram.
Last pa pala to. Kaya, sige. Ay,
May isa pa ako.
Schematic diagram ako.
May isa pa ako.
last.
Eh,
Okay, game.
yan ba yan? O, sige. Hydrogen atoms enter at the anode while oxygen is fed to the cathode. The hydrogen atoms are separated into protons and electrons at the anode with the use of platinum catalyst. The now positively charged proton processed through polymer electromembrane, also called the proton exchange membrane. Head to cathode, the polymer electromembrane or PEM is specially treated material that looks something like ordinary kitchen plastic wrap. It only allows positively charged ions to pass into while it blocks the electrons. The freed electrons travel through a wire creating the electric current. After passing through the circuit of the membrane, accordingly, once again with the aid of platinum as catalyst, the electrons and protons meet of the cathode, whereas by products.
Schematic diagram. This is schematic diagram. There's a row delivery para sa mga fuels and then mapupunta siya sa hydrogen FCs and then pag ano paliwanag to. So schematic diagram. Schematic diagram is meron magdadala ng truck ng fuel, mag-delivery and then mapupunta dito sa may tangke ng ng fuel and then mapupunta siya sa may hydrogen FC and then makakonvert siya sa may mapupunta siya sa may DC AC inverter and then pwede rin naman siyang madaan sa management unit and then mapupunta siya sa grid transformer and then magkakaroon ng local electricity grid. And then dito naman sa baba is meron ditong local buffer storage. So mapupunta ulit siya sa may hydrogen FC and then pag napuno siya is mapupunta siya parang mag-produce siya ng parang ang makukuha mo naman din is yung mga warm water. Ialis dito siya padadaan sa ilalim, doon dadaan yung mga warm water. So, I explore it. So, fuel cells has several benefits over combustion-based technologies currently used in many power plants and passenger vehicles. Hydrogen is very efficient fuel source capable of producing more energy per pound or per than gasoline. This means that an equal size tank of hydrogen fuel would give vehicle greater range or more power than when filled with gasoline in an internal combustion engine. Excuse me. Fuel cells have much lower emission than combustion engines. Hydrogen fuel cells emit only water, so there are no carbon dioxide emission and no air pollutants that create smog and cause health problems at the point of operation. Also, fuel cells are required during operation as they have fewer moving parts. Why hasn't gone mainstream? So hydrogen production through methane. About 95% of hydrogen used today is produced by a process called steam reforming. Separating hydrogen atoms from carbon atoms in methane. This process is expensive and it releases greenhouse gases, which contributes to global warming, thereby canceling out of any benefits to the environment. So, hydrogen produced through water is other production method is electrolysis, which separates hydrogen from water. The downside is that expensive. For hydrogen to reach its full potential as an energy source, scientists need to figure out a way to produce inexpensively from clean renewable resources. So the cost is fuel cells can be high, given they use platinum as one of the largest component materials. However, there is a work underway to find non-platinum catalyst approaches. Hydrogen storage. Scientists are still struggling with the challenge how to store hydrogen because it has such a low energy density. Hydrogen needs to be kept under strong compression to be viable fuel source, necessitating strong tanks and heavy duty fueling lines as there is currently no mainstream system of storage and distribution for hydrogen fuel. This is a major practical disadvantage. Hydrogen leak. So hydrogen leakage can occur during many steps of production and use. Science magazine reported in June 2003 that hydrogen leakage from whispered use of hydrogen fuel would gobble up ozone faster than CFCs do. Latest development. So, long-range energy generation project touted as the first of its kind power plant in the United States, the Long-Range Energy Generation Project, 8484 MW facility being equipped to run on mix of natural gas and carbon-free hydrogen is nearing completion at the site of the former aluminum smelter on the banks of Ohio River. The facility first will burn a fuel blend that includes 5% hydrogen in a General Electric H-class gas turbine. The plan is intended to transition to 100% green hydrogen over the next decade by relying increasing on renewable energy to power electrolysis machine that split water into its hydrogen and oxygen elements. Lang po, thank you. Huh? Kala ko last na yun. Siemens Energy. Construction begins on world largest green hydrogen power plant, part of unique base load solar project. Siemens Energy will operate the unique 100-meter facility in the remote part of French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts of night. A unique baseload renewables project that combines the world's largest hydrogen power plant with 16 megawatt machine for electrolysis of water, a 3 megawatts fuel cell, 55 megawatts of solar panels, and 20 megawatts to 38 megawatts per hour of batteries has begun construction in French Guiana, Collins 2020.